Aloha everyone, and welcome to another Carbon 60 video by me, Kelmer. And in this video, I'd like to share with you the research that I've done in trying to determine the amount of Fullerenes and or C60, carbon 60, in a rock called Shungite. It seems like all the people that sell this thing called Shungite are saying that it's got C60 in it, and I would like to just share with you the science of whether or not it really does. So let's jump right in. The very first step in all of this is to understand the terminology. So if you don't mind, I'm just going to do a little bit of terminology, a little bit of geology, and then let's jump into the subject matter so that we're all on the same page. So the very first thing to understand is when you say what is Fullerene, C60, and Shungite, let's start with the first word, Fullerenes. Fullerenes are a carbon allotrope, and what that means, if you remember from your basic science, was carbon is one of the many elements on the periodic table, and when you take carbon atoms and you cluster them together they come out in different forms. Some of them come out in this amorphous form where they make up the poofy kind of powdery, or charcoal kind of carbon. And then the other carbon atoms form different structures in a crystalline as opposed to amorphous. And the ones that are most popular, the ones that pretty much everybody recognizes, is the graphite in your pencil or the diamonds on your wife's wedding ring. And so those are the types of carbon, and they're just pure carbon. But you take those atoms, those carbon atoms, and you arrange them in different structures, you get different allotropes. Okay, now one of the allotropes, which is the purpose of this video, is going to talk about Fullerenes, which is a crystalline type of carbon allotrope. Fullerenes also are in the same branch of allotropes as carbon nanotubes. So they come either as what is called essentially a caged molecule, or I'm sorry, caged molecule of carbon, or a tube of carbon atoms connected together. And that's what's called Fullerenes, or essentially carbon allotropes, but it's also a Fullerene. Okay, it's one of the carbon allotropes. Sorry. Okay, so then what are Fullerenes? Okay, so now as of nowadays, there's about 39 different types of Fullerenes that have been identified by science in the study. They are as small as C20, which is 20 carbon atoms clustered together in a form of a spherical, or you can either go ellipsoids, tubes, and other shapes, all the way up to C720, which is 720 carbon atoms clustered together to form a little cage. Now, our favorite, which is the purpose of my whole entire research and everything that I'm interested in, is a specific carbon molecule called carbon 60, which is one of the 39 Fullerenes, and this is the one that's probably studied the most. It's got the most interesting, attributes and things like that. But I just want to point out, and this is very important to this discussion, is that there are multiple numbers of Fullerenes. Fullerenes are one of many forms of carbon, and within Fullerenes themselves, there are many forms of Fullerenes, and C60 is just but one of 39. Okay, and so now we ask yourself, well, what is Shungite? Well, Shungite essentially is a fossilized organic material of the sea bottom, Precambrian sediments that have a high level of carbon. And it's a rock, okay, and it's a rock made up of the bottom of the seafloor, a couple billion years ago. And then what makes it unique is that it's got a high level of carbon, but it's also got silica and silicate mica and other trace minerals. It comes in different types. I'll get into that more later, all the way from type 1 all the way to type 5. And these are when you look at it, it's pretty much going to look like these two different types. But there's 5 different types of Shungite that exist. And so that's when people are trying to sell it to you, that's what it looks like. Now, in terms of like how old it is, and I'm going off on geological nerd chip here because I'm really into this kind of stuff. But this is basically a timeline of planet Earth, and it scientifically stating, and started about 4.6 billion years ago. And then Shungite right here formed about 2.0 to 2.1 billion years ago in the Proterozoic eon, which is the largest eon on planet Earth. And so it kind of it's kind of cool. The oceans formed after the first snowball Earth, and then over time, basically, the planet froze over again, and second snowball Earth, and so forth. Dinosaurs showed up, etc. And then the first hominins about 2 million years ago. So you could say it was a really long time ago that this ocean existed, and over the time and the the tectonic plates shifting around on the outside of the Earth, the crust crunching together, it buried that ocean floor underneath the ground, and it heated it up and pressure and so forth, and it created what we now call shungite. And where you find shungite is specifically right here in this area of Russia on the border of Finland, and that's where that specific type of rock exists. But what I want to point out by this slide, and I found this to be absolutely fascinating because I didn't know this, it was the idea of fullerenes in general, right? Having a terrestrial and extraterrestrial origin. So if that's of any interest to you, there's a fascinating paper that was put out by the Department of Earth Sciences at Rice University in Houston called Terrestrial and Extraterrestrial Fullerenes. And so, if you've been in the C60 type of community for a little while, you heard, about a year ago, some folks started saying that C60 was a technology and all that kind of nonsense, right? But here's a paper that just absolutely dispels any concept of the fact that C60 was created. I mean, it exists on our planet. There's 17 identified locations on planet Earth that fullerenes exist in nature, and of course fullerenes exist in the universe, in the space, but we're talking about just the one right here in the area which is called Karelia, Russia. And so when you take a closer look at that area of Russia, like I said, it's on the border of Finland between the White Sea and the Gulf of Finland, and at the northern border of a lake called the Lake Onaga. Okay, it's about 60 kilometers northeast of St. Petersburg. So that's right there, that little red dot, that is the Shungite field from a mine. We talk about geological mining terminology. This is their field. This is a substrata map of that field. I got all this from geology type of documentation, but it's specifically. Oh, by the way, if you're not familiar with my videos, I link everything, so you can do all your own research. Don't trust me; just read yourself. All in the video description, there's links to all of these papers. Okay, so knock yourself out. I highly recommend people do their own research, learn for yourself, know what the truth is, so forth. So anyway, so here's a substrata map of Lake Onaga, the northern shore of Lake Onaga, by the Bay of Provenetsky. And here's the town of Shunga, which is what Shungite was named after. And then I highlighted these other two, all of these little words here, which I can't pronounce, are all other mines that are mining this giant field of Shungite underneath the ground. And in this paper, it talks about this field right here holds about 2 or 20 million tons of Shungite is mineable in this area, and right now all of these different Russian mines are pulling out about 200,000 tons a year of Shungite, and they use it for all sorts of different industry types of purposes and different materials and paints and you name it. So it is a pretty valuable rock that they're able to exploit economically, and it makes up a big deal of the economy in this area. So it's a pretty, it's Shungite by itself is a pretty interesting thing. I don't want to go too deep into that, but it's really interesting to read about. But so now these other two mines that I highlight right here, the Poga, and the Zaghogno mines are two of the ones that are mentioned in the literature about fullerene. So I just wanted to highlight so you can have a visual idea of where Shunga is at the northern end of Lake Onaga, and where the mines are, where people took samples of samples of Shungite to measure the amount and or detection of fullerenes in these mines. So this is where it came from. This mine here and this mine here are where the samples came from, which is interesting because there hasn't been any. I couldn't find papers about that had samples from any other mine other than these two mines, and generally, in general, the Karelia area. So as I mentioned earlier, Shungite in the literature is considered highly heterogeneous, and so what that means is it has more than one phase as it's forming. So there's a difference between a carbon allotrope and a heterogeneous element of a specific type of rock, and what this means particularly is that you can find shungite in 5 different types, and the types have been classified based on the amount of carbon that that type contains. Okay, so that's type 1 all the way to type 5. So if the rock has less than, or the shungite rock has less than 10% carbon, it's considered a type 5, or if it has more than 75% carbon, it's considered type 1. And so that's your concept here. If it's really low in carbon, it looks like this, but more carbon it has, it actually gets quite crystalline looking and very shiny. And so that's what that means. So this is actually kind of important, because when scientists start looking at different shungite, it's real important, like, okay, well, what type of shungite were you looking at to see if the fullerenes existed, which begs the question, are there fullerenes in all of the different types, or just 1 or 2 types, and so forth. And so what's interesting was that the literature does come out and say that they found fullerenes in type 1, 2, and 3. So there is, fullerenes in these that have been detected. And so now let's get into the actual reference papers. And so I want to point out something I think is very important is, after literally a couple of weeks of just some concerted effort, and I have a day job, so concerted effort outside of the day job and on weekends where I'm pulling up papers and researching and reading a lot. I found 21 separate papers on the concept. And I read them all, and I just kind of narrowed it down to there's only 5 out of 21 papers that really talked about the presence of fullerenes, and even more important, which is what I am very interested in, was the presence of C60, the 1 out of 39, right, of the fullerenes. How much of that was in there? Not just that there was fullerenes, but so the fullerenes and shungite, it kind of narrowed down to 5 papers, and the origins of these 5 papers come from the International Journal of Advanced Scientific and Technical Research, the Geological Society of America, National Geophysical Research Institute in India, and the Indian Institute of Chemical Technology, and also to the St. Petersburg State University in St. Petersburg. So there was 5 out of 21 papers that actually even gave me or anyone a glimpse of the concept of fullerenes in shungite. And so here are basically the results that I extracted from those papers. There are links to all of those papers. Everyone is welcome. Full transparency. I'm not trying to disrupt the shungite market or anything, but I want to just be really, really transparent, very clear, and very honest, scientifically accurate about this, okay? And the reason why it's important is you'll see at the end of the video. So the very first paper, and I did number them, so they're numbered right here, so I don't go, it's just there's not enough room on the slide to put the name of the paper. So paper 1, they went to the Zaghogen, I'm sorry, I just can't pronounce that. If you're Russian, I apologize. Okay, so they looked at type 3 shungite, and the results were, and it was right there in the paper, that they did detect that were fullerenes content in their sample, and it was anywhere from 0.01 to 0.0001% of the sample, and they looked at it through a transmission electron microscope, and they were able to detect that the size of the particulates of fullerenes were anywhere between 10 and 30 nanometers in size, and that's sort of important, because if you know your science, that you'll know that C60 molecule is approximately 1 nanometer in size, but right, that it does cluster together in crystals or clusters that could be anywhere from 10 to 300 or bigger. I mean, way bigger, where you can literally see it with the naked eye. You cannot see one molecule, C60, without an electron microscope, but you can see clusters of them in the hundreds and hundreds of nanometers. But so this size is the fullerenes, okay? And so so paper number 1 is they discovered and they detected that, hey, there's fullerenes in here. They did not look for C60. They just said there are fullerenes. So you don't know how many of the 39 or which ones of the 39. You just know that there were fullerenes in that sample. Their paper number 2 did not specify which exact mine. They just basically said they took type 2 shungite based on the description of the carbon content from the area of Karelia, and they studied it. And this second paper, was from the Geological Society of America. Okay, and they went and said, this is right out of the paper, we find no evidence of fullerenes in shungite sample from various locations. All right, and so they didn't find anything. The third one was the mine in Kondopoga, which I think is how you pronounce it, they studied type 1 and 2, and another study was type 1. The first one was out of 12 Karelian Shungite samples, we found Fullerenes in only 3 samples, of all of which were bright Shungite of glassy nature, which is obviously type 1. So they looked at type 1 and 2, and they only found 3 out of 12, and of course all 3 were found in type 1. And then the same individuals that did that study also mentioned in another study where they studied for C60, and this is what was interesting. The gentleman that did this was actually this paper here. Number 3 was in response to this paper here. So somebody put out this paper, these guys wrote a response, and then they did their own study. When they did their own study now, they actually went looking for C60, and this is the only paper I could find that even actually tested for C60, and it was just the one. And basically their results were that and they state this in their paper: the mass spectrum of the carbonaceous material from Shungite samples shows peaks corresponding to C60. And then they also took the material, which is the crushed Shungite, right, and they dissolved it in benzene, and they used a magnetic resonance spectrum, and it exhibited a clear peak at 143.2 parts per million, corresponding to the Fullerite C60 structure. Now, because it was the only one that even got close to even trying to identify, so I pulled it out of the paper. I just wanted you to see what their their graphics showed. This is out of paper number 4, and this is just basically Condopog mine in Karelia, and they ran it through the mass spec, the electron ionization mass spec, okay, and they did find Fullerenes, and they were able to identify, and this is what's critical, and this is what's really cool, is that they actually detected C60. One of the 39 Fullerenes, they actually detected it because they went looking for it, and that's 720 mole, and that's the weight of a C60 molecule. So when they saw that, they confirmed that it existed in natural Fullerite, okay. And then again, they melted it. They dissolved it in benzene, and they measured the parts per million of the sample in benzene, and they came out with this number. And this number is corresponding to Fullerite C60 structure. So I want to stop for a second here, and I noted this, and I just highlighted this word here: natural Fullerite, the Fullerite C60 structure. That does not mean that it is C60. It means Fullerite is another word for saying Fullerenes, or when you have a sample of a carbon sample, and there are multiple different types of Fullerenes in the sample, that sample is called Fullerite. Okay, and so they were testing Fullerite. They were testing a mass of Fullerenes, and they detected C60 in one of those samples. So that's fascinating. And so that was paper number 4. So so now we've got some confirmations of they've detected Fullerenes, they've detected C60, but then there's other papers here right at the same time saying that they didn't. And then I've actually read other papers where they looked at like meteorites, and one group of scientists said, yeah, there's Fullerenes on this meteorite, and another group of scientists looked at the same area, and they pulled out their samples, and they said there's no Fullerenes on that meteorite. So it's a huge depends. It really depends on what area, what type of Shungite, and so forth, or what mine, whether or not the scientists found Fullerene. So it's a big depends. It's not every single time you're going to find Fullerenes. That's pretty much it. Now the 5th paper, they didn't even study a sample. It just was a bunch of really super smart guys using quantum chemical calculations, and based on how atoms and carbon behave, and within the confines of the other atoms and different molecules within Shungite, they calculated whether or not C60 could exist. And it's a very interesting paper, and it's a lot of math, but basically they come out in their conclusion, and they state: a collective character of the self-organization of carbon molecules into aromatic structure is indicated by coinciding energies of formation of C60 molecules. And basically they said, yeah, it's possible, and based on the math. And the only reason I include that is because I couldn't find any more than this. This was all I could find that would even talk about whether or not it really is in there or not in there, meaning Fullerenes and or C60 in a rock called Shungite. So let's talk about that for a second. So this is what I learned. Number one was that, all studies focused on the presence of Fullerenes, not C60. And that is such a very important point to make. They went looking and they said, hey, we found some of these, but they didn't say how many of this, how much it weighed, what percent of the sample was just this, but as we found an existence or the presence of all of these, quote, they found Fullerenes. They did not get into finding C60 except for that one paper. And that one paper, I want to say right here, that it was only detected. It was not measured. They did not quantify, like what percent of every shungite you see in the world is going to have C60. No, they just detected it. And they primarily detect, and scientists primarily detected Fullerenes in type 1. Maybe there's that one other one that detected Fullerenes in type 3, but primarily, if you read them all, they primarily found it in type 1, not all of them. So it really, really, really depends what type of shungite we're talking about when you talk about Fullerenes and you talk about C60. But again, the presence of Fullerenes does not mean, that's 39 different kinds. It does not mean that there's a presence of C60. There's no quantifiable statement. And C60 was not found, it was detected, which is a big difference, right? And then also, too, I just want to point out again that I was unable, and I read a lot of stuff, and obviously, there's probably way, way more out there. I only have so much time. That's why I want to quantify my conclusion by saying that I was just unable to find any study that measured the quantity of specifically C60 in a sample of shungite. And if you find one, I would love to read it. So if you find one, about a study like that, please let me know. I would love to read that and then do a follow-up to this video, okay? So, that's as far as I could go with this. And then lastly, of the one paper, which is the paper right here that basically measured the actual percentage of Fullerenes, which is the paper here from the International Journal of Advanced Scientific and Technical Research, where they actually measured the amount. This is what's so important, right? I mean, it's one thing to say, oh, I detected something, but it's another thing to say, I actually measured the amount in the sample. And their measurement stated that there was 1 gram of shungite powder, inside of 1 gram of shungite powder. It had an estimated 0.01% to 0.0001%, which is like, if you looked at it as a gram, it's like 0.000001, or never mind, I'm just going off on a tangent, sorry. Okay, this is what's important though. Of Fullerene content, not C60 content, Fullerene. So if it's 0.01, let's just be, let's say from the guys who are trying to sell all this stuff to everybody, okay, let's just be really generous to you and say, okay, you're right, there is C60 in there, detected, but it's 0.01%. So that a percent is 0.01, right? So if it's 0.01%, it's 0.0001, right, grams per whatever, right, of Fullerene. But here's the thing, it's of Fullerene content. There's 39 different Fullerenes. There's no mention in that paper that how much of it was this. So let's say, okay, we could. I don't want to. Actually, I don't even want to speculate. How many of these were there? They measured that there was Fullerenes, but there's no idea of how much was of that was C60. You know that there's 39 Fullerenes, so it could be 1/39th of 0.0001 grams. That kind of thing. So I just want to conclude this video by stating, all right, let's be scientifically honest, and let's take this number and say if it's Fullerenes, then we know that C60 is a fraction of the Fullerene content, right? If you have Fullerenes, you have a fraction of that. So a fraction of this number, you take it to the, how many zeros do you have? And let's round up and let's answer the question. But before I do that, I just forgot, I wanted to mention something. A couple of weeks ago, I was on Facebook and I was kind of interacting with an individual who was talking about C60 in his shungite water. And I kind of just pointed out, I shared a paper with him that said, C60 doesn't exist in water and it's not really healthy for you. And then Chris Burris jumped in on it. It was fascinating. Chris Burris, if you don't know who he is, he's one of the founders of SES Research. This guy, they started their company in 1991, and they actually worked with the graduate students who were basically working under Smalley and Croteau, were the scientists who discovered C60 in '86 and had gotten the Nobel Science Prize in 1996 for their discovery. These are Nobel-winning scientists, and the graduate students that helped them with that discovery, Chris Burris worked with those individuals when they first decided to commercialize the production of C60 for the academics that would then start studying it, and then further on into developing it for commercialization in industry. And so Chris Burris goes way back. He's a 660 scientist times 1,000, right? And so he jumps in on this conversation, which was amazing to me. And he goes and he tells this guy, right? He goes, hey, Shungite was proven to not contain C60 by Dr. Smalley's group. Now, Dr. Smalley was the guy who was one of the 3 scientists who got a Nobel Prize in science for their discovery of C60. And he goes on to say, this is from the source, right? If my memory serves me correctly, and we're all hoping that Chris takes a lot of C60, so he's probably got a pretty sharp memory. But if his memory serves me correctly, they tested samples on 3 separate occasions, samples of Shungite. This is what we were talking about, because they really hoped there was C60 in Shungite, and they didn't find any, that there was proven not to contain. So Smalley's own group, the people who discovered C60, went looking for C60 in Shungite. They didn't do a paper on it. It's just this story that came out of the lab, and they did not find any. Okay, that's remarkable. I mean, I wish I could have, they would have wrote this down and I could add it to this, but I've got like a witness here that basically said, hey, they couldn't find it. And so now I'm going to get back to this right here. So if there's a estimated 0.01% of Fullerenes, and there's an estimated within every batch of Fullerites or Fullerenes, you might have 1 out of 39 different types. So let's just be generous and say, okay, it's point of this number, it's a fraction of that number. And science, what do you do in science? Well, you round up, right? You can't, you want to be scientifically accurate. And so the definition of scientifically accurate is, well, how many decimal points do you want to round up to just basically state whether or not something exists in a sample or not. And so I'm going to say, hey, well, I'm going to be out there and just speculate. If it's a fraction of this 0.01, and you add a few more zeros because you don't know what were the contents of the Fullerenes, and there was some C60 in there. But if it was more like this, we'll just take this end. Let's say if it's this number right here, okay? It's that this is the amount of the, let's just guess that of the Fullerenes, there was some C60, and at the end of the day, there's this much C60, 0.00001. All right. So then what do you do when you publish your paper? Well, most people will then round up. You round up the number to give you the number that you're going to want to claim in your paper that says this is how much of this stuff is in this other stuff, right? So here you go. This is my conclusion for discussion, okay, as of what I know today with all the material that I've read up to now. Okay, so I do reserve the right to change my conclusion with more data. But the question that I want to answer here for everybody, based on everything that I've just conveyed to you and all the material that I've linked to that you can look at yourself, is there C60 in Shungite? And I will say that there is approximately 0.00% C60 in Shungite, and that is a scientifically accurate statement based on the material in the science literature for this topic. And there you go. That's the answer. There is none. Or at least there is 0.00. All right, so that's it. So that's the conclusion, and I would love to be proven wrong, but that's all I can find, and that that anyone has ever proven. All right, so now one other thing I do want to get into before I close up, and I just want to talk about Shungite water a little bit, because over here, you see right here at the very end of Chris's post, he also says, additionally, C60 is not water soluble, because this gentleman was convinced that when he put Shungite in water that he was drinking C60 water, right? And so Chris is, being Chris, and he's trying to help the guy. Additionally, C60 is not water soluble. So you can put pure C60 crystals in water and you will not transform that body of water instantly into C60 Fullerenes. In other words, you put it in water, even if you have pure C60, you put it in water, it's not going to do you any good, all right, because it's not water soluble. So now I went looking for some literature on the subject. I want to add it to the end of the video, and I just want to share. So here are 2 studies on C60, or I'm sorry, Shungite water. Okay, one from St. Petersburg State University in Russia, St. Petersburg, Russia, and another Russian paper from the Institute of Geology and the Karelian Research Center. So these are two Russian scientific papers from Russia about, one is about the chemical composition of extracts from Shungite and Shungite water, and the extraction of Fullerenes from Shungite carbon by water containing solvents. All right. So when you put Shungite in water, are you drinking C60 water? Well, okay, that answers that. But okay, let's just get into it a little bit more. Okay. All right. So let's take a look at these two papers, and you'll know why I'm telling you this. The first one, St. Petersburg State University. This is right out of the paper. Go look it up. There's a link below. The interaction of ground Shungite with water gives a solution with rather high concentrations of a number of microelements, including heavy metals. The concentrations of microcomponents in aqueous extracts from Shungite 3 are rather high and frequently exceed the maximum permissible concentrations for potable and household water. This is Russian. These are the Russians telling the other Russians, don't drink this stuff. Okay, it's not even, it's beyond the acceptable limits for health. And this is what's important about this, and let me jump into this one before I get into that. From the Institute of Geology Karelian Research Center, comparative analysis of extracts obtained in Shungite carbon, that's what this symbol means, and C60 FWS, which means a donor acceptor complexes of fullerene and water. So that's fullerene and water. Fullerenes, now C60 fullerenes, which I don't even know what that really means, but fullerenes and C60 maybe, lead to a supposition that fullerenes and Shungite carbon are presented mainly in the form of chemical derivatives and strong molecular complexes. All right, so translation, it's a chemical derivative of a C60 fullerene. And what that means is it's not just C60, it's C60 with other atoms attached to it, like oxygen, hydrogen, silica, and it changes it. Once you add an extra atom to C60 of something else, it's not C60 anymore, it's something else. Okay, so these guys are saying that when you put it in water, and we tested it, you don't get pure C60. It will, like he's basically saying this right here in a very simple ways. It's not going to become C60 water. It doesn't. It becomes something else, like polyhydroxylated or that kind of stuff. It gets off into all these different other molecules, but they're not molecules of C60, which is my point. Now this is my last point on this thing. As I mentioned earlier, that the Karelian region pumps out 200,000 tons of this stuff a year. It is the basis of their economy in that region. It is a big deal. They have a lot of economy, a lot of money, a lot of people's working lives at stake about whether or not Shungite is a valuable rock and used in industry, and it is. Okay, so there's a huge economic incentive, right, to promote this thing so that the world wants to buy more, right? That's just clear, right? Let's all be adults. This is, sometimes science does not necessarily represent the best interest of science when money's involved, right? Especially at that level. So what comes is really shocking to me is that there's two Russian papers that basically say, not good, doesn't have it, doesn't have C60, and don't drink it. Okay, and that's what was really surprising. But these are Russian papers. These are Russian, and St. Petersburg University is highly renowned. So there you go. If the Russians themselves are saying that Shungite water is not good, and especially not good, but not healthy for you, I just want to really point that out for all of you guys who believe that C60 or the Shungite has C60 in it, and for all of you that believe that drinking Shungite water is healthy for you. The Russians themselves are telling you that it's not. So I really just please exercise caution, because we're all in this together, and the science says this is probably not a good idea. All right, Shungite water, or believing anybody that says this load of BS right here, please exercise caution. If anything in my research that's more alarming to me than anything else was, I went on eBay, I typed in the words C60 Shungite, and this kind of BS showed up. This guy here selling C60 for, literally, C60 for olive oil or olive coconut oil, genuine high quality natural fullerene. Okay, that couldn't be a bigger load of BS based on what I just told you and all of the science material on the subject. This one here, Shungite powder, Karelian stone, Fullerene C60 pure powder, C60 pure powder. Oh really? Oh really? Did we not read the paper? So this is a absolute false advertising scam. People are buying this crap, probably adding it to oil and poisoning themselves with what? Heavy metals. So please don't do that. I just feel bad when I think that people are actually doing that. So it's alarming to me. So anyway, I just that's that. So please exercise caution. And one last thing. I went looking at this one. This guy has a website, and he claims that he has a patent. And he claims that he's got a safety data sheet on this product. So I looked at the patent. And the patent has nothing to do with C60. It's a patent for grinding Shungite stone into powder. And I looked at his safety data sheet on his website. It was a safety data sheet for the use of Shungite as an additive to mattress linings for beds. It had nothing to do with safety for ingestion. It was just complete BS. So yeah, enough on that. I'm sorry I went on a tangent, but it's personal to me. I don't want you guys to see any one of you guys get sick. So that's it. Here's the answer. There's approximately 0.00% C60 Shungite, an absolutely accurate scientific statement. Thank you. Thank you for staying with me on this video and learning with me as I go along in my journey to know more about C60. I hope that this put this to rest. I hope you guys can link it to your friends who think the opposite. Don't fall for the marketing hyperbole. It's just that. It's the truth is the truth. Okay, it's the 0.000. So thank you for your time. It is valuable, and I do appreciate it very much. Thank you for your kind comments. I hope you have a great week, and aloha. Have a great day. Bye.